Hello students, in this video we'll discuss Enneper surface. We can consider the Enneper surface which has the following parameterization: R of U and V, R of U and V is U minus U cubed over 3 plus U V squared, and then V minus V cubed over 3 plus V U squared, and then U squared minus V squared, okay? So let's start out by finding the first fundamental form, right? So in other words, this is a self-intersecting minimal surface. And we're going to prove it's a minimal surface. Great. All right, so let's find the first fundamental form. So what's RU going to be? So RU is going to be 1 minus U squared plus V squared. And then 1, then just going to be what? RU over here is just going to be a 2UV. And then finally a 2U. My RV over here is going to be what? My RV is going to be a 2UV. And then a 1 minus V squared plus U squared, and then a minus 2V, like that. Great. All right, so let's find the first fundamental form. So of course our first fundamental form is going to be RU dot RU du squared plus 2 RU dot RV du dV plus RV dot RV dV squared. That's my first fundamental form. So let's do RU dot RU. So RU dot RU, RU dot RU is going to be this expression squared over here. So if I square 1 plus U squared plus V squared squared, that's going to be a 1 plus U to the 4th plus V to the 4th. Then the U's are going to be negative, right? So I'm going to have a negative 2U squared V squared. We're going to have a negative 2U squared. And then finally, we're going to have a plus 2V squared, plus 2V squared. From that first term over there, just expanding it out. Then a plus 4 U squared V squared, and then a plus 4U squared. Okay? So if we simplify this, what do we notice over here? So we notice over here that we can replace, so these things over here, and that will turn into a 2. And then we have a 4U and then a 2U that's going to turn into a plus, that's going to turn into a 2. And then finally we have a 2V squared. So I have a 1 plus U to the 4th plus V to the 4th plus 2V squared plus a total of 2U squared V squared plus 2U squared. That's a perfect square itself. That's 1 plus U squared plus V squared squared. Beautiful. All right, so that's the first component. Now what's my RU dot RV? So RU dot RV, we can just trivially check that RU dot RV is equal to 0, right? So how would we check that? So we have a what? We'll have a positive 2UV over here. Over here we'll have a positive 2UV, then we'll have a negative 4UV, so the UV terms cancel out. Then we'll have a what? A negative U cubed times 2 times V. Over here we'll have a positive 2U cubed times V. Those will cancel out. We'll have a 2UV cubed, and over here we'll have a 2UV cubed with a negative sign. So RU dot RV is equal to 0. RU dot RV is equal to 0. There's no middle term in my first fundamental form. Great. What's RV dot RV? So RV dot RV, RV dot RV. Let's do the same calculation. So it's going to be a 4U squared V squared, U squared V squared, and then a plus 4V squared from the last term, and then a plus this thing over here. So that's going to be a plus 1 plus V to the 4th plus U to the 4th. That's when I square all the individual terms. Then I do the cross terms. So I'm going to have a negative 2V squared, a negative 2U squared V squared, and then finally we have a plus 2U squared. And again, if we check what's going to happen over here, we're going to have the same exact structure over here. That's going to be a 2U squared V squared. We're going to have a 2V squared, a 2U squared, and then perfect squares. So this is also the exact same thing. So we have a perfectly conformal metric, right? Like that. Beautiful. So now my first fundamental form, I, is exactly this expression, 1 plus U squared plus V squared, quantity squared, times du squared plus dV squared. Beautiful. So we have our first fundamental form of this Enneper surface. Great. It's a conformal mapping, so it preserves angles. Okay. Now let's compute the second fundamental form. So how are we going to do that? I'll need the second derivatives to do so, right? So I'm going to have an RUU. RUU is going to be what? RUU is going to be a negative 2U, a 2V, and then a 2. RUV is going to be a what? RUV is going to be the vector of this is going to be 2v, and then a 2u, and then a 0. RVV is going to be what? RVV is going to be a 2u, then a negative 2v, then a negative 2, like that. Great. Now I need to compute the normal vector of this thing over here, so how are we going to compute the normal vector? So let's do it. So it's across these two things over here, right? So my n vector is going to be what? Well, first of all, it's going to be n is going to be RU cross RV. So if I do n hat, it's going to be RU cross RV over the length of RU cross RV, which is going to be an EG minus F squared. So it's just going to be RU cross RV divided by what? It's divided by EG, and EG is going to be what? So EG is going to be this expression times this expression. It's going to be 1 plus U squared plus V squared to the 4th power over there. Beautiful. Okay? And it's going to be the square root of this thing over here. So in other words, that's going to be, it's the length of that thing, so it's going to be the square root of this thing. So it's going to be the square root of this expression. So we're just going to get the factor of 2. So it's going to be RU cross RV over 1 plus U squared plus V squared squared, like that. Beautiful. Now let's do RU cross RV. So let's do that next. So it's RU cross RV. All right, so what we're going to do, we'll do RU cross RV, we're going to have this times this minus this times this, right? So that's going to be a negative 4, and then a UV squared, and then a negative of this thing over here. So that's going to be a positive 2UV squared, a plus 2U, and then a, that's got a minus 2U rather, so that's a minus 2U. But a minus 2u, and a minus 2u cubed. That's my first entry, right? What's my second entry going to be? Well, my second entry is going to be the negative of this whole expression over here. So let's do this negative of this thing. So it's going to be a negative. So let's actually do that negative and just do it by hand, right? So we'll simplify this in a second over here. Good. And so what are we going to have over here for the v entry? We're going to punch this out. So we're going to have this times this with a negative sign. So it's going to triple the sign. That's going to be a 2v, and then a minus 2vu squared, and then a minus, or plus rather, a plus 2b cubed, and then I got rid of the minus on this one over here, so I got a negative on the opposite side over there. That's going to turn into a plus, and it's going to be a negative. So negative is a plus 4u squared v plus 4u squared v. Great. And then what's the last entry going to be? It's going to be this expression times this expression minus this expression times this expression. So it's going to be 1 minus u squared plus v squared times 1 minus v squared plus u squared. And then that's going to be subtracted from 4u squared v squared. Okay, great. So let's simplify this. So it's RU cross RV simplified. RU cross RV simplified is going to be what? Let's see over here. So we're going to have a factor of, all these things are going to be negative. We're going to have a negative 2u, negative 2u cubed, and then a negative 2uv squared. Great. Then this thing over here is going to be a what? A positive 2v, a positive 2v cubed, and then a positive 2vu squared, which is what we want to see. That's great. And then the last thing over here, so let's FOIL this out and see what we're going to get, right? So we FOIL this out carefully, what are we going to get? We're going to have a total of what? We're going to have a total of a 1 minus v squared, 1 minus v squared plus u squared, a minus u squared, a plus u squared v squared, and then a minus u to the 4th, and then also a what? Then a plus v squared, and then a minus v to the 4th, and then a what? And then a plus u squared v squared. So all total, this last entry over here, if we look at this last entry, it becomes what? It becomes 1. Now let's see what's going to cancel out. The v squareds cancel out. The u squareds are going to cancel out, right? So I have a 1 minus u to the fourth minus v to the fourth, and then what? And then a plus uv minus vv, that's a minus 2u squared v squared, like that. So this last entry over here is going to be what? Is going to be 1 minus 2u squared v squared minus u to the fourth minus v to the fourth, right? And then so therefore my n is going to be this expression over here. We're just going to divide it by this quantity over here. So now let's find the second fundamental form, right? So what is going to be my second fundamental form? My L is going to be RUU dot n hat. So I'm going to pull that factor out. That's going to be a 1 over 1 plus u squared plus v squared squared. And then if I dot this expression over here with a negative u, what are we going to get? So we're going to get this expression dot this expression over here. So this is going to be dot with a negative 2u, so that's going to be a total of 4. Then everything has a u, so I'm going to pull a u squared out. And then what's going to be left over here is I have a 4u squared. And then what's left is going to be if I pull a 4u squared out of there, I'm going to have a 1. If I pull a 4u squared out of this thing over here, then we'll have a total of u squared. And if I pull a u squared out of this thing over here, 4u squared out of this thing over here, I'm going to be plus d squared, plus v squared. Good. The next term over here is going to be what? The next term is going to be, so we can just clear this out of the way now. Next term, dot n hat. I'm going to have a 2v dot this thing over here, so that's going to be a total of, I'm going to have a 4v squared out of everything, 4v squared out of everything, right? And then we're going to have a 1 left over plus a v squared plus u squared. Great. And then finally over here, what's going to be left over here when we do this last thing over here is going to be a 2 times this thing. So we're going to have a 2 times this whole expression over here. So that's going to be a 2 minus 4u squared v squared, and then minus 2u to the fourth minus a total of 2v to the fourth. Great. Okay. So let's see what this simplifies to over here. This is going to simplify to what? So how many u squareds do we have? We have the u squareds are gone, right? So in other words, this u squared over here, and that's 2v squared over here. So those are going to cancel out. So let's see what we're going to get all total. So let's be a little bit careful over here. So we're going to have a 2 over 1 over 1 plus u squared plus v squared squared. And then what's left over here. So we're going to, let's count all of our terms carefully over here. So we have a total of, let's count. So we have a 2. Takes care of this term. Let's look at the u squared v squared term. So we have 4u squared v squared, 4u squared v squared minus 4 from a total of 4 u squared v squareds. And then what? And then we're going to have u to the fourth terms over here. So we're going to have a 4u to the fourth plus 4v to the fourth. So that's cancel out 2 of those. So I'm going to have a 2u to the fourth plus 2v to the fourth. Like that, times 2. Great. I can pull out a factor of 2 from this expression over here. And if I do that, what do I see? This is going to be 2, and then it's going to be 1 plus u squared plus v squared, single power over here. So it's going to be 2 over 1 plus u squared plus v squared, like that. So one of the factors is going to cancel out. Beautiful. Okay. And what's the second one going to be? So if I want to do, now if I do want to do m, the middle one, and the middle one is ruv dot n hat, right? And so what we're going to get is we're going to get a 1 plus u squared plus v squared to the negative 2. And then we're going to dot these things over here. So I dot this with a normal vector. We're going to get a 2v times this thing. So I have a 2v times negative 2u minus 2u cubed minus 2u v squared, right? And then a plus 2v plus 2u times the v terms over here, which are these expressions, right? Which is exactly what? Which is exactly going to be a, what we have over here. Good. And then a 2, where's my expression? So it's right over here. Right here. 2v plus 2v cubed plus 2vu squared, and then plus a 0, right? Now, of course, what's going to happen over here is we're going to see if I multiply all these things out over here, we're going to have a negative 4uv, a positive 4uv, a negative 4u cubed v, a positive 4u cubed v, and then a negative 4uv cubed and a positive 4uv cubed, right? So in other words, this m term over here is exactly equal to 0. Beautiful, right? And finally, let's do n. So n, the last term in the second fundamental form, is going to be rvv dot n hat. And what's that going to give us? That's going to give us a what? Same thing over here. 1 plus u squared plus v squared to the negative 2. And then we're going to have a 2u times this thing over here. So if I multiply all that out, everything's going to have a factor of at least a 4u, right? So if I have a 4u squared and then a what? If I have a 4u squared and then a negative of all these things over here. So negative, a negative 1. So I'm going to pull that negative sign out, right? So that's going to be a negative sign. And then a 1 plus u squared plus v squared, like that. Over here, the v's are going to be negative now, so I'm going to have a negative 4v squared, 1 plus v squared plus u squared, like that. And then a negative 2 times the n component, so it's going to be the opposite of this thing over here, right? So it's going to be this expression, but opposite. So negative 2 plus 4u squared, v squared, plus 2u to the fourth, plus 2v to the fourth, because it's just the opposite and negative over there, because you're dealing with a 2, right? Beautiful. And so now, of course, this is exactly the same thing as this L, except with the opposite sign. So this exactly is equal to what? So this N is equal to what? Is equal to negative 2 over what? Negative 2 over 1 plus u squared plus v squared, like that. Okay? Beautiful. So those are the coefficients of my, and these things are squared, of course, right? So we have to be a little bit more careful. So actually, in other words, and what's going to happen over here, we had one slight algebra error. What's going to happen over here is that this is squared and this is also squared. So they're going to completely cancel out. So in other words, this will completely cancel out. So that's going to be just a negative 2, right? And then this thing over here, that's just going to completely cancel out. Not all of the factors in the denominator cancel. So this is actually going to be, so go and correct your notes, because this thing is exactly 1, that's 2 times 1 plus u squared plus u squared. So that's going to be just a positive 2. And this is going to be just a negative 2 over here. Beautiful. So now my second fundamental form is what? My second fundamental form 2 is just going to be 2 du squared plus dv squared over here. Excellent. Now, of course, if I want to look at this matrix over here, beautiful, so that's my second fundamental form. And of course, that's going to be a negative, not a positive. So the dv term is going to be a negative. So that's a negative over there. Not bad. Like that. Excellent. And so now, of course, if I look at 1 inverse times 2, what does this matrix look like? Well, this matrix just looks like the following. It just looks like a matrix that looks like a 1, a 0, and a 1, and then a 2, and then a 0, and then a 0, then a negative 2. And this is all scaled by what? This is all times the factor 1 plus u squared plus v squared to the power negative 2, right? Because that's the inverse, that's the determinant of that matrix over there, right? And it's going to be to the power negative. That's going to be the inverse of this thing. Is going to have this thing flipped and then this thing flipped. And so if I divide, if I multiply each of those expressions by that expression, I get this over here. And so what that allows me to say is this allows me to conclude what the kappas are, right? So in other words, kappa 1, the principal curvatures of this thing, so kappa 1 is going to be positive 2 over this expression over here, right? And then kappa 1 is going to, and then kappa 2 is going to be negative of that thing over there. So my principal curvatures, kappa 1 is equal to negative kappa 2, and that implies that h, the mean curvature, which is kappa 1 plus kappa 2 over 2, is equal to 0. So what we've just proven over here is that we've just shown by this calculation that since the principal curvatures are equal and opposite since it's a diagonal matrix, right? So in other words, I can see over here that the principal curvatures up to this factor over here, they all scale by that factor, are going to be what? Are going to be 2 and then negative 2 up to that factor of 1 plus u squared plus v squared is negative 2, right? So that proves that this Enneper surface is actually indeed a minimal surface. So by computing the first fundamental form and second fundamental form and seeing that they have a very special structure, we're able to construct our first non-trivial example, our first example of the self-intersecting minimal surface. Thank you very much.